When people talk about range hoods, they almost always talk about suction. Suction has become the most marketable metric in this industry. Consumers buy suction, manufacturers sell suction, media tests suction, awards compare suction. Over time, one idea quietly settles into everyone's mind. More suction equals a better range hood. The problem, suction everyone understands but doesn't. Yet, most people's understanding of suction is actually vague. It feels familiar, but hard to explain. People believe in it, but can't clearly define it. In that sense, suction has become something like pseudoscience, widely accepted, rarely questioned, and poorly understood. So if suction is the center of the conversation, then it's time to bring it back, from intuition to physics, reframing suction scientifically. Instead of treating suction as a single number, we can break it down scientifically into 3 physical dimensions: magnitude, reach, direction. Once you do this, many long-standing problems suddenly make sense. Part 1. The 3 dimensions of suction. 1. Magnitude. This determines how strong the negative pressure is. Right at the intake. Simply put, can it pull air at all? R. Reach. This determines how far that negative pressure can extend into space. In other words, can it pull from a distance? 3. Direction. This determines whether suction aligns with the actual rising path of smoke. That is, can it pull from the right direction? Why this matters in closed or semi-closed systems, like vacuum cleaners or steel ducts, engineers mostly focus on magnitude. Why? Because boundaries already guarantee reach and direction. The environment does the work for you. But a kitchen is not a closed system. It is an open space. Air naturally equalizes pressure. Negative pressure decays rapidly with distance, and airflow direction is easily disturbed. In open environments, reach and direction, not magnitude, become the limiting factors. Part 2. The structural limitation of traditional suction. For decades, the range hood industry has focused almost entirely on increasing magnitude. Bigger motors, higher airflow numbers, lower intake positions. On paper, suction looks stronger. In reality, only one dimension improves magnitude. Reach remains weak. Direction remains unstable. Lowering the intake does shorten the distance, but it introduces a new mismatch. The suction direction does not align with the natural rising path of smoke. This turns smoke capture into a reactive process. At its core, the industry made a structural mistake. It applied suction logic from closed systems to an open environment. The result is an incomplete form of suction. Strong nearby, weak at a distance, misaligned in direction, and unreliable at the source. Conclusion. The biggest problem with range hoods is not that they lack suction. It's that they rely on only suction. Real breakthroughs won't come from pushing motors harder. They will come from giving airflow, direction, path, and spatial control. Only when suction is treated as physics, not belief, can the industry move forward.